Hello everyone. Today we are going to do a few review problems. Tonight's homework has a review sheet as well. There are so many different types of reactions in this unit. It would be a very long assignment if I tried to put all of them on a single assignment. So I encourage you to not just look at tonight's review sheet, but also look at the problem sets that we've done up to this point for practice as well. Okay, so we're going to look at two problems today. These both require sort of backward thinking. We're given products and we're asked to find the reactants that would have formed those products. Okay, so this is a kind of mechanism called structure elucidation, where we're figuring out the original structure by looking at the products it forms. Okay, so this says substance X is treated with ozone and methylene chloride and forms the following lone product. Okay, so ozone is used to cleave double bonds and form either a ketone or an aldehyde in the place of the double bond. Here, I see these two functional groups that are both ketones that would have formed from the ozonolysis of this molecule. Because there's only one product, that could mean either two things. It could mean that the molecule was symmetrical, it was cut in half and both products are identical. That would be possible if there was only one ketone or aldehyde group on this molecule, but because there are two, it looks to me like this is going to be a ring in which the double bond was cleaved and opened up to form a molecule that has these two carbonyl functional groups. Okay, so to find out how many carbons are in this ring, I am going to circle the carbons that are attached to the carbonyl groups. Those are the ones that are going to be in the double bond, and then simply count the number of carbons between them. And as I go, I'm going to number them, and this will come in handy later. Okay, so I've got 6 carbon in this ring, and I've numbered them 1 through 6. We'll see the reason I numbered them is so that I can pay attention to which carbons have the functional group. We have methyl groups and isopropyl groups. So I'm first going to draw a 6-membered ring with a double bond. Okay, now looking at my numbered carbon, I can see that the double bond is on carbons 1 and carbon 6. Okay, and now I've got a few other functional groups. I have a methyl group on carbon 1 and a methyl group on carbon 2. So I'm going to put a methyl group on carbon 1 and a methyl group on carbon 2, and I'll number these two just for clarity. Okay, and I've got an isopropyl group on carbon 6. Okay, so this would be my final structure. It would have a methyl group and an isopropyl group on the central or on that double bonded carbon. Okay, so again, we figured that out through working backwards, and I think numbering the carbons helps a lot in making sure they don't misplace one of the side chains.